Today it's going to be a bit shorter. I usually have up to 2 hours, maybe an hour and a half, but I actually have a meeting that I need to attend later tonight. So I need to, I actually designed the meeting today to be around 1 hour, give or take, maybe 50, maybe 50 minutes, maybe a bit more than an hour, but not a lot more. Before I start and then start sharing, second. Oh, where is my PowerPoint? Here it is. Okay, so first of all, looking at the team window and I see a few new faces. Welcome. It's great to see you joining us. Hopefully you enjoy. I'll have a quick introduction in the beginning. If you want to introduce yourself, please go ahead. I do know that a few of the people that join, and I do see some new faces. So, do you wanna introduce yourself? If you're new in the group, you don't have to. No, okay, that's fine. So, but welcome. I'm super happy to have you with us. Let me share the whole screen. Do you see my screen?
Yes, looks good.
Okay, good. Okay, so basically the agenda is pretty short, as I mentioned. I initially had only this part, my best C++ 11, 14, and 17 features that helped me write a better code, which is labeled as beginner to intermediate, but I definitely think that beginners class would find this laundry list of things that are very useful, not very complicated, but very useful to improve your code quality. Should be a very good list to keep in mind. But I couldn't skip the C++ quiz, so I have about 2 questions. One is easy, one is not easy that I didn't get the right answer. It was kind of very hard one, but again, it's kind of a random C++ quiz website. Just give you a random quiz. It's not like I pick it. So before we go to the agenda, a few things about you know, administrative things. First of all, it's sponsored by Qualcomm WRD software, which I'm part of. So thank you, Qualcomm, and thank you for my VP Charles supporting that for more than 2 years. So Qualcomm is paying our meetup fee every 6 months. So thank you, Qualcomm, for supporting that. It's very important for the community and promoting C++ in San Diego and outside of San Diego, because I know that some people are either joining online outside of San Diego, but also watching the recording that is uploaded to our San Diego C++ meetup channel. We have a Dropbox link. By the way, if you can't access it and you don't have a way to look at the slides, which I'm uploading after the meeting, please let me know. We have a Slack channel, pretty much that it's still there. We have a very alive Discord, like relatively alive, that Martin, is Martin here on the line? Let me see. No, but Martin actually brought the whole thing into a very active state, and it's being used for questions and announcement and so on and so forth. So so we do have, I do need to update the link, the invite link from time to time. So if you don't have, so I do update the invite link in the meetup.com website. So if you wanna join the Discord, try that. If not, just ping me. As I mentioned, I'm recording the meeting, uploading to youtube.com channel SDCPPMU, so San Diego C++ Meetup. We have about, I don't know, 15, 16, 18, something like that sessions that are already uploaded. I didn't record from, so this meetup is a bit more than 3 years, running a bit more than 3 years. And initially it was in person. Then the whole COVID started, and I think I started recording maybe a few months after the COVID started. So we have a Twitter handle where I have announcements. I do have my own Twitter handle, which is Kobe_CA. And CA is not California, by the way, though it's matching very nicely where I live. But no, it's the initial of my last name. Uh, Practical Modern C++ blog, where I have a section that if I have time, I blog there. So I have a few blogs over there that you can take a look. But outside of my blog, there's millions of other very useful and interesting information from Martin. So feel free to go there. I really like his blog. Okay, without further ado, if is there any question, by the way? No. Okay. So we start with cppcast quiz, and then we'll go to the main slide deck with the features that I mentioned. Let's start with the cppcast quiz, and then we'll go to the other section. And I want that to be interactive, so I'll explain. Okay, so what I'm going to do is share my okay. So that's the first one. So according to cppcast 17, so I told you there is one which is lower difficulty, and then there's a bit harder one. So let's take a look at this. And this is a very good question because it's emphasized something which is very important, and it's kind of a easy to trip if you're not paying attention. So it's a very important question. Uh, so we have two structs, and again, it could be class. Struct is just everything is public. So there is a virtual function here named print. There is no virtual destructor. Not a big deal in this case, but do have virtual destructor in your base class in the case of runtime polymorphism. So the special exception is inheriting from general exception. It's overriding print. This one prints G, this one cout S. We have a function f that throws special exception, which is the derived class. Now we have the main. Main has a try catch. It calls f, which throws. And then we have a catch that catch general exception e and e dot print. And the question is what's gonna be the output? Is it gonna be compiled? It's gonna have compiler error? Is it undefined? Is it unspecified? So take a moment, and you can shout anything you want. It's very interactive. What do you think would happen? So let's say it would print something. It's gonna print either G or S, right? What do you think it's gonna print, and why?
Wouldn't it print S because of the override?
So it should print S, right? That's basically also what the author here was probably intended, right? But there is no reference here.
Oh,
there is a name for this behavior, and the name is slicing. What happened here is the whole idea of polymorphism, where you actually invoke a virtual function through the base class. It's through the base class pointer or reference, which basically it's like a pointer. But what happened if you have a derived and you pass it to something that accepts a base class, but not by reference, and it's not a pointer, but it's actually a value. It's actually a copy semantic. What happened here is that general exception is not a pointer, it's not a reference. What is left from special exception is only the general exception. It's only the base class. So inside here, E is really a general exception. The whole special exception was sliced, even though there are no members and all, but conceptually, if you think about how the structure would look like, general exception is the base class, special exception is derived, but when you pass a derived to something which is not a reference, it's not a pointer, there is something that happens, and this thing called slicing. We're slicing the 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 derived is sliced to be left only the base class, and e.print would be the base class only, which means it's going to be G.
So
And
this compile, I was
this
just going to ask
compiles.
Jacoby.
Yeah, it
Okay.
compiles. And
I'm surprised there's no warning, at least something.
you know what? I is there a, let's see. It's actually, C++ warning on slicing. Okay. So slicing is very simple. You have a derived and you create an instance of it. This is a very, very simple, very simple example. You have a base, you have a derived function that takes a base, not a pointer, not a reference, but just the base. You create an instance and you pass. Is there a warning? Let's see. Doesn't seem like there is something like that. Yeah, there's all kinds of this stuff but there is no way. Like, you could argue that, oh, sometimes I want slicing for whatever reason. I honestly, in my entire career, never wanted to slice something, but it might have a small use case. I wonder if
Maybe the fact that it doesn't have a reference means that you're trying to communicate that what you want is only a general exception in the copy constructor. So maybe then the slicing would be appropriate, but it's like I guess it's a type conversion from the point of view of the compiler.
Well, base class can accept anything that is derived from it, right?
Yeah.
So slicing or not slicing, it's gonna accept it. But I don't remember seeing any. So if we take this whole thing and put it in God world, let's reset the whole thing. What else can we have? I don't know. I don't know if there is anything that can warn us. But yeah.
I think there's a cling tidy flag, but I don't know about the actual compiler.
Yeah, if someone, we can definitely. It's a good question, Jim. What I would do. What I usually do, because I can't remember the entire. Oh, here, the startup project. Can't remember all the warnings. So what I usually do, I go into, did it change all of this? Where is it used to have a CMake. Figure file, maybe? No, it used to have, it could change that. It used to have a CMake module that has a CMake file that has all the warnings for all kinds of compilers, and this is usually what I no, I don't. I can't find it right now. Interesting. Maybe it's here, but no, it shouldn't be on there.
I think he moved it to like an external project under like project properties or something.
I haven't looked at it for a long time.
Yeah.
Maybe the boilerplate project. Okay, it's on my to-do list now to kind of hunt it. It's very useful. So he had he kind of, I think he kind of refactored the whole thing. So usually that's what I use. I take a look at the warnings for, he has like GCC, Clang, MSVC. Anyway, I from the top of my head I can't think about anything. Oh, I didn't want to share it. 1 second.
So this was, Kobe, this was basically a list of warnings, and then you just search through the list. Sorry, I interrupted.
Yeah. There is a list of warning that he has in this as part of his CMake file. So okay, let's continue and I'll figure it out.
Somebody else had a question, Kobe. I think Wes.
Please go ahead.
Yeah, I did. Thank you. On that last question we were just looking at, you made reference to it being copy constructor, which is why it was printing the general exception. If it was by reference instead, would it print the S for the special exception?
Yeah, if it was by ref. Oh, here, there is a warning. You see? Catching polymorphic type by value. Hooray, we do have a warning. Okay. So nice. So if it was by okay, so let's first of all let's we just needed to look at the output of the compiler. That's it. Okay, so let's do this. Let's I'm executing the code. You can see it's G. Right? You can see it here. Now I'm gonna have a reference. By the way, const reference is the right approach because you don't want anything to change. But yeah, so it's S.
Okay, thanks.
Yeah. And if I was doing something like throw new, let's say I'm not deleting, okay? It's gonna be the same. And I need to do arrow. So reference and a pointer would activate the real purpose of the polymorphic idea, okay? But if not, it's just sliced. And I'm pretty happy that GCC has that. Okay, the next one is pretty hard. I don't know if anyone would remember that later, but I definitely didn't get it right because there is a very, very small section in the standard that actually explain what happened here. So what do you think? Anything goes. Is it going to be compiling? First of all, there is no output, there is no printing, so there is no so that's already goes out of the door. But it's either compilation error, unspecified, or undefined. Give a wild, take a wild guess. It's undefined. And the reason for undefined is the following. The only single valid specialization. Okay, let me backtrack for a second and explain what's happening here, because if you're new to variadic templates, it's going to be a bit overwhelming. So templates had a small facelift in the new standard, and we got variadic templates. Variadic templates means that when I instantiate a template, I can pass for the same template type. I can specialize it for all, not specialize, but instantiate it for all kinds of template parameters number, okay, including 0. So you can see that 0 is here. There is no, but I could have x of int, comma, double, and so on and so forth, and it's going to be valid. What's happening here is that there is in this specific case, Okay, there is a var that accepts 0, comma, like its initialization, comma, all the args. And this dot 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 would be expanded to all the arguments that are being passed here in the constructor. Okay. So there are variadic templates, and the constructor would take each type and it's going to be expanded. So if I had an int comma double and I'm passing 3 comma 7.0, there's going to be two parameters and two arguments that I pass to this constructor. And there is in this specific case, it's a very stupid code, but because it's wrong, it's undefined behavior. But in this case, there is an integer that takes initialization, and usually an integer would take initialization of an integer, and that's it. There is no. It doesn't make sense to have an initialization of integer with multiple of parameter or multiple arguments passed to this initialization. It doesn't make sense because there is no such thing, right? So, well, it does make sense if you talk about the syntax, because you can have like the comma would eventually have the only last one, but it's pretty evil, right? So so what happened is that here the only single valid specialization that the only one that is valid is this one, when there is nothing and var is initialized with 0. And for example, if, however, there are template arguments, they are expanded to invalid initialized list int, such as var and this comma. So this whole thing is nonsense. So the only valid specialization of X is the one with no argument, which is this one. And apparently there is a clause in the standard that says that if there is only single valid specialization required, requires an empty template parameter pack, so the program is ill-formed, no diagnostic required. When no diagnostic required, the compiler is not required to diagnose, and execution of the program is undefined. Okay, so the only valid one is the empty template parameter pack. They decided that this is an ill-formed program. Ill-formed program, no diagnostic required means it's undefined behavior. So I wasn't aware of this specific clause, but it is where it is. Okay, this is very tough. Let's go with it a bit more sane topic. And this is basically designed for people asking questions when I present all kinds of features. So if you have anything that you would like to share, or any idea that you would like to describe, or any question, just let me know. We can stop and talk about it. So it's basically a slide deck that has everything that I thought that is very useful when you write C++, more than C++ code from 11 all the way to 17. I'm not including 20. There are some slides here are not more than C++ related, but also it was already there in pre-11. But I thought it's important to make a note of this specific feature. But it's mostly 11 and above. And I was recently interviewed in cppcast. There were two different interviews, and at least in one of them, I think in the second one, I mentioned that there is a set of features that we are using, that features in C++ that help us to write very robust code and easy to maintain, and so on and so forth. And I wanted to share that. I didn't really explain in details. There was no time, of course. So I wanted to. So I came up with this. I don't know. There's like, I think like 30, almost 30 slides here of what I thought would be important to share with you. Modern C++ is really a game changer. It helps a lot in many domains, in many aspects of writing good, robust, correct code that is easy to understand, easy to reason about, sometimes shorter, hopefully shorter. That's what we want. Obviously, it's everything that I'm going to show has context. Your mileage may vary, and maybe something that was working for me would not work in a different context. You need to measure. That's the bottom line. If I remember, when I talk about the specific features that might be a bit more expensive, it really depends on the context and what is the trade-off and what is the other option that we had on the table. All the examples here are cooked up examples. It's something that I came up with. They're not the real code, but they are definitely providing enough context and information how being used. It's not a comprehensive syntax or usage. It's much more than that. We need many days to cover everything, but it gives you the most important thing, in my opinion. I'll start with auto. There is some order of importance, but not necessarily. Like there are some things towards the end which they're still important. Okay, so auto introduced in C++ 11. It is something that is inferred in compile time. If you're coming from other languages that are strongly typed like Rust, it's pretty much very similar to type inference. There is no, it's not like Python or anything like this. There is a type that is known, that has to be known in compile time. Now, in some cases, it's really easy to just write auto and forget about it. And there are many points in your code that you don't want to write the actual type. Why? Because it might be complicated. It might be maybe long and verbose. And sometimes you don't really care because it kind of a pass through. So take a look at this example of func, where I return auto as the return value. No need for a trailing return syntax. And I have x plus y, and I don't really care about what is x and what is y. Maybe it's a pass-through function, and maybe x and y today are integers and tomorrow will be double. And I want auto return value to be adapted to the future changes of x and y. I'm actually designing that to be this way. So in this case, auto is playing like a very important role. There is something that I would like to highlight, which is one of my favorite C++ 14 features, which is auto in a Lambda. It's basically a polymorphic Lambda in the sense that this auto is creating a template function of the functor that is being generated for us. And this auto here is super useful in some cases where you have, in this case, you have an algorithm that removes something that returns non-zero in this expression when val is modulo 3. So in some cases, the items that goes into this parameter, so the argument that are being passed, are maybe a bit complex. They have some specific type, and you don't want to specify it, and you don't want to make mistakes, and they might change. So auto would be a very good choice. It does some, there is some criticism about having auto everywhere, which might be obfuscating the code a bit because you don't know what the type is, and sometimes it's really hard to write code. But I'm specifically using CLion as my IDE, and I with the type annotation, I have zero issues. Actually, C-line it's doing so well even with complicated types like ranges. So I don't have any issues with understanding the type. Ranges for loop. So I would say that if you don't need, at least for up to 17 or maybe 20, if you don't need the index, don't use the old for loop. There is a trend, a positive trend about looking at algorithm instead of for loop. But if you need to reach up for a for loop, the range for loop is a much better choice than using an index. And if you're coming from other types of languages like Python, and again Rust is another one that they have, and others that they see a specific element as for example the container, that it is something that you can iterate over. You don't really need to specify, and it's kind of an anti-pattern. And not that, for example, in Python you don't do a for loop with a len. You just use the iterator capability of a specific element, right? You don't use index as well there. And they have enumerate, which is another thing that that we have in Python. We don't have it in C++ up to 17, but actually even 20. It's much better. You don't need, like, if vec, you don't need to have any index. You get the actual values. This is the value that I'm getting by value, but you can have auto as a reference. Again, usage of auto here makes the whole thing very, very generic. So it's shorter, much easier to reason about, and no need to think about all these indices, and it makes the code much more robust. No need to dereference iterators. All of that goes out. Okay, I already mentioned Lambda in the auto, and I also mentioned generic Lambda, but I want to have a specific slide on that. So Lambda is basically, there is a very nice set of recording, C++ Weekly recording from Jason Turner, that talks about all kinds of features that Lambda support. And what he mentioned in one of his recording, maybe some of the recording, that if you go and take a look at every single Lambda feature, it's basically everything, or maybe almost everything that the standard has. It's squeezed into this feature named Lambda. So Lambda makes things very easy to use in terms of algorithm, because we have locality of the code as long as Lambda is really small. There is also things like immediately invoked function expression or Lambda expression, which is what you see here. I have a Lambda here, and I can pass 4. This 4 would be bind to X, and it's gonna print 8. This is a very simple, stupid example, but it's being used in other contexts, which makes things very easy to write, sometimes in generic code. So Lambda is one of the things that makes our code much better and much easier to understand, makes the whole standard algorithm usage much easier. So it's very recommended to at least understand how it goes. And every standard would have a new set of features that being added to Lambda. People really like it. Explicit constructor are basically our default constructors that we use when we create a class or a stack that has a specific constructor. And the idea behind it, and some people like Jason Turner, if I'm not mistaken, mentioning that this should be should have been the default. It's catching all kinds of issues when you need when you don't want to have temporaries created. So long story short, constructor is a conversion operator. So if I have a const char p, which is like a pointer to character as a parameter to foo, and I have this function that accepts foo by, in this case, const by reference, because I'm creating a temporary. So this hello, if I don't have explicit, the compiler would go out of its way to create. So, okay, can I create a foo from a character pointer? A character pointer array. Let me see. Do I have a constructor that takes a character pointer array and I can create a foo instance out of it? Oh yeah, I do have it. If there is no explicit here, the compiler would create a temporary, and since the temporary would bind to a const reference, it's going to create that and use it. So you have a temporary that would be created. Might be an expensive temporary. Explicit means that no, you cannot do that. You cannot use foo constructor in this way as a conversion operator. You cannot convert character array to foo. So it makes, and I know in fact that a lot of just mistakes of creating a temporary happen if you don't have an explicit, and this whole thing is gone once you stick to have it in explicit. Now, if you do need foo here, so this would not compile. This code would not compile. But if you do need, you can always create an explicit call to the constructor at the call site here. Create a temporary and have this code compiled. It's fine, but it needs to be explicit. And I don't think that people, including myself, think that should have been the default behavior is a C++ 17 attribute that was added named no discard. And I think in 20 there is also a way to pass a reason, or not a reason, but a message that would print it if you discarding. What does it mean discarding? So I'm creating an instance of foo. This is just I create a temporary. It doesn't really matter. I could have it just an instance, and I'm calling get, and I'm not taking any. I'm not dealing with the return value, and the return value is marked as no discard. So obviously, this would create an error for me. There are all kinds of ways to say I want to ignore that. I personally use std ignore. There is a way to static cast. It's also legal, but I use std ignore. So in this case, I would have std : ignore equal foo dot get, and std ignore would swallow that. And it's basically very descriptive that says, I know that there is a return value, but I don't care. And I might have a comment saying why I don't care, but sometimes I don't. I just don't care about the return value. The author of get thought it's important for you to look at the return value. In this case, get might just return an integer, just a 7. Like, why would you call get if you don't pick up this 7? Unless there is all kinds of side effect happening here that you want to invoke get just because of the side effect. So yeah, I can understand that. But if get is just an accessor to an integer, it's pretty strange that you have that get without grabbing the return value. So no discard is a great kind of a firewall between, okay, all kind of, oh, I forgot to pick up I just had an expression and sorry, a statement, and I wanted to make it an expression, and I forgot to look at the return value. So so that's a very useful one.
Kobe, quick question.
Yeah.
Is there any other use for that no discard? It's just for return values?
From what I know, yes.
Okay, I was just curious.
Yes. Unless I'm forgetting something, but we only used it for return values.
Okay.
And again, for 20, when I create new projects in CLion, I think I'm picking at least 20, maybe 23. When I write bracket no discarded, it's CLion is completing that for me. It gives me an empty quote, so there is a paren, an empty quotes here that I can fill with something that would go into the error message. And sorry, by the way, of my voice, I'm a bit under the weather today, so okay. The next one would be no except. Now, no except is a bit strange. I specifically put that here, but it's kind of a dangerous feature if you're not using it correctly. At least this is my opinion. On leaf calls, oh, this should be leaf, not lead. On leaf calls, it should be straight, like return 5. There is no exception, that's fine. But if I'm calling as another function that I don't know if it's throwing an exception, it's not marked as no except. Having no except that calls something that might, that it's not marked as no except, would create an additional code inserted here. So what I'm trying to say is that just like const is kind of it's a feature that once you put const, everything else needs to be const correct. Otherwise, things would not compile. Here, no except would compile, but you don't understand that it's gonna generate more code. Why? Here's the thing. No except in this context tells the compiler, look, whoever calls f guarantees that no exception would happen. Okay? So, and it's part of the signature. So when I have no except, by the way, this is a typo. It needs to be no except and no. It needs to be like this. So when I have the definition, and I can't really promise that no exception would escape, the compiler needs to write code that makes sure that the guarantee that we had for the caller of f would hold. Okay, so we said that we are no except, but we are actually throwing an, not us, maybe a function that we invoke would call an exception. We need to terminate because we have a contract that we don't honor. Okay, so if nothing happened, there are no exceptions, everything would work fine, but there's more code that is added, and more code that would make your function a bit more slower. So be careful with it. It needs to be used in very like in a very you need to make sure that you investigate every path. Make sure that what you mark as no except is really no except. Otherwise, things would be a bit slower in runtime and more code would be generated.
Kobe, what's the use case for this? Is this to assure the caller that they don't need to write an exception handler?
Yeah, there is no exception handler that needs to be written. You guarantee that there is no exception happening coming from out. Now, in some cases, there are operations that needs to be marked as no except in order to for the standard library can pick them up. For example, move constructor better be no except. Swap better be no except, because there are some things in the standard library relying on the fact that no exception would meet it. So if it's marked as no except, it can be used. Otherwise, maybe a different thing would be specialized that is less. It might take more time in terms of runtime. It's less efficient. So it's specifically for few functions and few paths in your code. It's really important. Like swap is one of them. Move constructor is another one. For example, if in some cases, if you try to move something and your move constructor of your type is not no except, it might fall back to copy. Then it's not going to move. It's going to copy because your move is marked as except because you don't have no except. So So that's all kinds of, and your move constructor might call something that also needs to be no except. Right.
One last question is there a counterpart to no except for the purposes of the caller? Let's say that, you know, I'm writing the code and I want to make sure that I don't have an unintentional exception occurring. Is there some notation in my function that assures that everything I'm calling is no except? If you know what I mean, you know, because I only know about the things that are at the top level of the call tree.
Not that I am aware of.
Okay.
I thought you when you start asking, I thought you were asking if there was a way to say this is actually going to might throw an exception.
Okay.
So no except, especially an operator, you can have a paren, you can have no except an expression. Let's take the simple approach. You can have no except true. No except true means that it's really no except, but no except false means that it might throw. It's actually an operator. So it's very useful in template metaprogramming where you have a function, for example, with a no except, and then a paren with expression that is relying on the template parameter. And for example, you have a constructor T and then paren, and then the compiler would look at T paren and say, okay, is this going to throw or not? If yes, it's going to have a no except true. Otherwise, it's no except false. And it's basically a very useful operator in metaprogramming. I don't have an example here. It's kind of more on the
okay. Yeah, I think
part.
I follow what you're saying. Yeah.
So it's actually an operator. And there is a recent blog post that happened this week from the new old globe. I can't remember exactly the name of the blog. That talks about no except, like twice, no except, and why there is twice. Why do we need to have twice? So there's a very nice blog post on that. If you want me to post it, if you can't find it, let me know. I'll post it on the Discord channel.
Okay.
Okay. I already mentioned we have first of all, we have more overload on the algorithms, and we have a bit more algorithms like IOTA and things like that in 17. But we also have, because of Lambda, it's become much more accessible. It became much more easy to use algorithms instead of using maybe handcrafted functions or loops and so on and so forth. Now, obviously, you need to measure everything, and as people that know me from Qualcomm, I have this weekly session where I sometimes have all kinds of small algorithms that I compare all kinds of methods, including ranges and other C++ algorithms, and I put it on benchmark, and we can see how they stack against each other. And sometimes ranges would be better, sometimes some accumulate would be better than others, and it really depends, and it becomes even more chaotic. I know chaotic is the right word, but it's harder to reason about when you throw in all kinds of parallel algorithms. Now it depends on the input, and there's from a specific input size, it might worth to go into parallel algorithm, but with a smaller one, the overhead of parallel algorithm would not worth it. So measuring is probably one of the most important thing that I would suggest people before going into like jump the guns. Okay, this std algorithm would be better than for loop, or this for loop would be better than std algorithm. Take a look at, just try to microbench it, maybe even more than microbench it, and see if it makes a difference. And was another thing I wanted to mention. And it's, yeah, sometimes I have an assumption, I guess something and I put it on benchmark. And today with Conan and ranges and all of that, it's really easy to bring all of this into your workspace very easily. I have a guess, and sometimes my guess is not correct. I had some intuition. Oh, this for loop would be better than this. It's not happening. Sometimes the algorithms would be very it would work very well. And compiler optimization is really good in vectorizing, and you can't really make an assumption and like just going with a some gut feeling. It's better to measure. There is a very nice not blog post, sorry, a podcast named Two's Compliment that I really recommend people to look at, basically listen to, and it talks about performance, and they keep repeating what I just said. Optional. So optional is a very nice new type in C++ 17 that I tend to use if I need to have to specify a semantic of there is a value, but sometimes there is no value, and I don't want to use 0 because 0 is a valid value, and I don't want to have -1 because -1 might be a valid value, or I don't want to use null pointer because null pointer might be a valid value, but I want to say there is nothing. And just like in Rust, there is some and none. It's basically very similar to that. There is a option in Rust. We have optional. It does come with a bit more of a small overhead, but again, measure if this is a deal breaker. Usually compilers, optimizers are doing a very good job removing that overhead. But again, measure. In terms of semantic readability and mutability, it's a great type. It's a great tool. You can see that I have a class here that has this integer. There is a j here that might be here or might not. And if you think about configuration that that has a data members, let's say that foo is the configuration class. Sometimes a specific configuration attribute just doesn't exist. Like there is no default value, just doesn't exist yet. And how do you basically model doesn't exist? You need something like optional, unless you have all kinds of magic numbers saying nothing. This is nothing, like invalid handle or invalid number, and you keep this enum and you compare. Using optional is really easy when you compose it into the overall expression when you use it. It's a very good tool. Tuple or tuple, I don't know what's the best way to pronounce it. I can't remember, but it's basically an improved pair that we use it when we really don't want to create a struct. It's like there is a delicate balance between this pair or tuple versus a named struct, and sometimes it is useful to have just a bunch of types, and it's readable enough. If it becomes not readable, I would definitely opt for a named struct with a name variable or attributes name. But it is something that improved our pair to something that is almost unlimited. It's always limited because there is a compiler, there is a like the compiler has some stack when it compiles, but it's almost virtually unlimited number. Okay, const and const expert, all the things. So obviously const expert is something that a lot of the community is on board. People like const expert instead of using pound define. I basically const everything, and there is some this some all kinds of opinions about should we const everything? Should I basically const everything? There are some cases, not a lot, but some cases where this hint of const helps the compiler to optimize. It's very small case, but in terms of I'm kind of like doing what Rust is doing, which is I have const like immutable by default. But some people, they don't like it because it adds verbosity. which I understand, but I basically have const everything. In my opinion, easier to reason about mutability, and when you look at the specific code. Again, const expert is much more important. It's a new thing. Const is not a new thing. Const expert is something that is superior to pound define, like pound define something like val. Having const expert is much better because const expert is conforming, or yeah, conforming is a good word. Conforming to the language syntax. Pound define is a preprocessor. It's a search and replace. It is very dumb. It doesn't know about language rules. Const expert knows about scope, knows about namespacing, knows about everything else that the language provides. Pound define would not. So variant and visit definitely helped us in state machines. There is obviously penalty that associated to this. Again, you need to measure, but it's super helpful for state machines. And there are multiple blog posts with cppcast 17, because it was introduced in cppcast 17, talking about stud variant. There was another blog post this week about stud visit, by the way, that it's doing more than visit. It's actually a very interesting thing to see what stud visit is doing. But having this variant of types and be able to put them in such syntax where you have a way to take a variant that holds something, either state 1 or state 2, and dispatch it to a specific function according to what in runtime, what we have here, what state is holding, makes the code much, much easier for when dealing with state machines. So again, we used it in few cases in our code, and we didn't feel that it slowed down. We measured it, didn't feel like it was any major slowdown that kind of alarmed us. I do know that some people might shy away from that, but we found it very useful in terms of readability, mutability, and shorter code dealing with state machines. Another thing that is kind of a more syntactic sugar and readability wise is using stud byte. We just want to have a type that doesn't have a sign. We don't care about sign. It's just access of raw memory. And basically byte defined in C stud def, and it's basically looks like this. It's a kind of enum class byte, and it has its own. It's basically its own enum class type. You can reinterpret cast it if needed. And it just make things a bit more readable in terms of this is not a unit 8 or whatever. It's just a stud byte. It's just a raw memory that we want to access. It makes things a bit more sane in terms of readability. But I do see it as a more syntactic sugar, unless I kind of forget like what is the main thing that like another compelling reason other than readability. Oh yeah, it's a by only collection of bits and only operator defined for its bitwise one. So there's no arithmetic. So that's another thing to remember. You can't accidentally do some arithmetic. It's just bitwise. You can do this plus this because it's not uint 8. It's just stud byte, and it's being enforced because it's enum class. One of the things that I want to highlight, it's not really related to cppcast 11. It's something that I still wanted to highlight, is that we made sure that there is no punning. Like we don't have reinterpret cast and basically type punning. The right approach to make sure that there is no undefined behavior is if you have this struct and you have this foo, and you want, let's say there is a buffer, let's say from network, and you want to take this buffer and make it and have it into foo, this mem copy would not actually do a mem copy as you might think. It's basically going to have an instruction that actually just I don't know if point is the right way, but it's not going to have a real mem copy happening here. It's just populating this foo with the bytes, but it's not mem copying. It's something much more. It's not calling mem copy. That's the bottom line. And if you look at the instruction set that it's being generated with optimization, obviously, you see that it's and this is much cleaner in terms of undefined behavior versus this. Yeah, this needs to be a foo pointer, by the way. So sometimes people wanted to take a look at the buff as foo pointer, and they would have reinterpret cast or ccast, which is basically the same, of foo pointer. This needs to be pointer. This is an undefined behavior in some context, and this mem copy is a much better approach. Okay, in class initialization, I might need to put it somewhere at the top of the slide deck because it's really important. It's shorter. You don't need to write constructors. It makes things much easier in terms of the order of initialization. You don't need to think about order of initialization. It's just initialized this way. This specific class, when I initialize I and j as 5 and 3, would be as if I have a constructor with 5 and 3 initializing I and j. There is no, oh, I forgot to initialize the. So it's if you're writing a class, use in-class initialization as much as possible because it helps tremendously in writing correct code and not forgetting anything.
Is this in C++ 17?
No, this is 11.
11? Oh, okay.
Yeah. Very, very useful. Okay, variadic templates. So I already mentioned variadic templates. I'm gonna just touch upon it very, very. We didn't have like a whole lot. There's some specific code that is generic that we needed to have variadic template is really contained in one location because it is still something that relatively more advanced and people usually looking at all these ellipses and dot and it's pretty it might be a bit intimidating. So it's only contained in specific generic code, specific part of the library or executable code that we needed that to support specific use cases, but it's super useful. It makes life very easy when you start working on instead of writing multiple overloads with all kinds of template parameter number. This makes things much easier. So just think about it when you start thinking about, oh, I have this overload with one parameter, I have this overload with another parameter, and so on and so forth. Think, in this case, think about variadic templates. I have one slide on atomics, mutex, threads, future, promise, all of that with very, very small examples. In C++ 11 and then 14, 17, and so on and so forth, we're getting more and more syntax related to threading, atomics, all kinds of RAII locking, like scope lock, lock guard. Scope lock, basically, it's a newer one which has a variadic template here compared to logguard. Unique lock, which is basically also a scoped lock, but has a bit more functionality to lock and unlock, which is used in condition variable, and threading. The threading is a bit lacking. It's still lacking some of the functionality to look at the specific attributes of the threads. I don't know if it's going to be fixed in next versions, but there are workarounds. So there is a way to, platform specific way to access the handle and do something like change affinity and similar. Default delete is, again, one of the important things that I would like to highlight. Default means I don't want to write an empty constructor because I have a constructor full of int. once I put a foo of it, just an example, if you have any constructor, you're losing the default empty constructor. But if you need to bring the default empty constructor, we didn't have a way to do it before cppcast11. We needed to write an empty constructor. We have a way to do it in a better way. Instead of defining it with an empty curly braces, we can have equal default. We can delete, tell the compiler this is not we're removing it from the overload implementation by using equal delete. It's a very useful. You can remove constructor, you can remove even function overloads. So it's a very useful feature that was added in cppcast11. And again, the default one is important. If you need to have a destructor, a default destructor that has an empty body from any reason, let's say virtual empty destructor. If you do need it, you don't define an empty one, you just have an equal default, which is a much better one than having an empty curly braces. Okay, CTAD is basically class template argument deduction. Again, some people like it, some people don't. It is the way for the compiler to understand what is the template. So vector is template, right? It's a vector of T. But if I have stud vector of v1, 2, 3, the 1, 2, 3 are all integers, the compiler can say, oh, this is all integers, and it's a stud vector of integer, and it's shorter. The problem here is that people that are not familiar with stud vector, maybe your own type, might not know or realize that this is a template, and maybe they do want to know. So readability wise, it's kind of hiding the fact that it is a template. cppcast14 enabled something that called heterogeneous lookup. It's a big, relatively big topic, but in a nutshell, what I would say about it, that it allows us to have an efficient lookup when I have something that is not quite the key. Let's say I have a map or a set or an unordered map, an unordered set. So unordered map and unordered set features of this heterogeneous lookup was added in 20. If I have a key, something that I would like to look for in this container, and the key is a specific type, and I have a different type that I'm holding that is not quite the same as the type, I can make it. If I'm not using this heterogeneous lookup feature, there's gonna be some conversion that happens, and I'm gonna pay in runtime penalty. Heterogeneous lookup enable us to still use something which is compatible to the key type without paying for the runtime penalty. It's a very kind of a niche, not super known feature, but super useful. When you get to it, it actually saves you a lot of cycle times, especially if you do a lot of search and a lot of access to the specific associative container. And this is, I think, for upsell. So just Google heterogeneous lookup in C++, and you'll get the cppcast14 and 20 improvement. And there are a few blog posts. If you can't find it, let me know. Stud function is a way for us to specify a specific function. It is using something they call type eraser, so it does have some runtime penalty. I do know, because I was tracking this specific type, that older compilers used to be much slower than newer compilers in terms of generating an efficient code, not compile time, but generating efficient code. And stud function it's very convenient, but again, it's using type erasure, which means there's some runtime penalty. But it's really nice to have void, some function that returns void, and there is an integer that is being passed as an argument. So there's one single parameter, and it's very useful to just use it and just assigning all kinds of functions with the same signature and just keep it. So it's just readability wise, it's much better. You just measure if it doesn't work for you, you need to fall back into just function pointers. And this is my last slide. Just happened to be final, but it is the final slide. It's kind of a controversial one because some people like Vittorio, they don't really like it, and I definitely understand the reason behind it. So the argument behind it is that sometimes I do want to subclass from this specific class type, and by not having this, by having final, I cannot subclass. The reason that I used it a lot in the code, I'm still using it, is because I have a very traumatic experience in my 23 years using C++, where people, including myself, at least in the beginning, I barely subclass in the past many years. But there's a lot of abuse happening with subclassing and inherited and increased complexity, increase the mental burden that we have when we need to read code, because it has a hierarchy and you don't know what exactly, because how do you know when you have few layers of a few level of inheritance, how do you know what exactly is your interface? What exactly is your augmented size or augmented attributes? You don't. So it's pretty hard. And I decided that in order to stop this, I'm putting final. Yes, it means that if someone wants to inherit because of a good reason, it needs to go and ask from the author to remove that, but it needs to have a good reason. So I still think it's a good and useful feature, but some people disagree, and again, I definitely understand why they disagree. Yeah, that's it for today. This is what I had. There any question? Is there any specific feature that people feel that they had a lot of improvement once they start using it? Any other something that I mentioned or something that I didn't mention yet? Or at all? No? Okay. So hopefully this is a very it's going to be a very good list for you to kind of stick and use it. I'm going to upload the whole slide deck soon into the Dropbox. If you don't have access, please ping me in the either meetup or our Discord, and I'll help you to retrieve that. Okay, so that's it for today. Thank you. Yeah, sure.
I have a small question. What's your stand about a for range loop versus for each? Which one will you choose? Do you even use a for range loop now that you have for each?
I sometimes do use for each. I didn't mention it here, but I kind of implied in the algorithm. So I do use for each. If the for loop, the problem with for each is that people have some because of the verbosity, people say, okay, but I can have a for loop and or a single statement, like why do you need the for each? But the for each is sometimes might be a kind of more readable, even though the verbosity is high. So I'm kind of on the fence here. I do write for each when I need to iterate, but just trying to think what when basically for look when you have for each and you yeah, it's basically the same. You don't get the iterator, you get the actual value. Oh, I tell you why sometimes I use for loop and not for each. So let's say you do a for loop. You want to iterate over a map, a stud map, and you want to deconstruct, which I didn't mention here, the structured binding, cppcast 17 structured binding, which I didn't mention here, which I should. When you want to deconstruct you could would do. Let me show you. Let's say int and stud string. Yeah, I'd say you populate it with, I don't know, 1 and okay, so you have something that is already populated. It doesn't really matter. Okay, now let's say I want to do something like this. So basically, I can have it's const. So I can stud clog whatever I and s. Basically, they are strings, right? So I need iostream here. So this is a 17, and I should have mentioned that this is a very useful one, where you yeah, it's okay. Where you can actually have this pair deconstructed into I and S. So you can say one hello, 2 word, right? So it's in this case it's much easier in the for each loop. It's more verbose, and then we have this, and I'm gonna be lazy. So this is the pair. Now the problem is that I have so now I need to have something like in order to achieve the same, but so in this case, I usually opt into the for loop. You can definitely do something like the following, which is valid. You can deconstruct them, and its reference it's gonna be optimized. You don't need to worry about it, but you need to have this additional thing where here it's kind of provided without any issue. And I'm using Ordo, so basically this is, you can think about it like a template. So if you look at the CPP Insight, So you can see that right here. This is the Lambda. Yeah, this is the template parameter. So this would be a template. Otherwise, I need to do something like stud pair const int because it's const, and then stud string because this is basically the right pair. It's a const int. Otherwise, it's not going to work well. Does it answer your question, Gil?
Yes. And
okay.
one more mini question. I'm not sure. Did you mention a unique pointer and shell pointer?
I did not. I should probably do that. One of the most important things. Yeah, I don't know how I missed that. Yeah, because if you already mentioned that, I think my opinion is that yeah, I'll add these 2 slides, the structure binding and the memory part. I'm barely using shared pointer. It's really in this very specific case where I don't really have an owner. It's really usually in message passing like this, something that is moving through a pipeline and there is no owner. So it's 99% is unique pointer. What I'm trying to say is that in cppcast, modern cppcast, you should not have no memory leak and no memory corruption on all of that, like double delete and all that should not happen. I don't remember the last time since I started working with modern C++ syntax, it doesn't happen anymore. So yeah, thank you for mentioning that. So before I upload the slides, I'll add these two slides about structure binding and unique pointer just to have it complete. If there is any other feature that you think that is useful and I missed, and definitely this is possible, just let me know. Okay, thank you everyone. Hopefully you enjoyed and you learned something new. I'll see you next time. Take care.
Thank you.
Thanks, Kobe.
Thank you.
Thanks, Kobe.